If Pittsburgh can land on the moon, Pittsburgh can do anything.
America's next mission to the moon, controlled from right here in Western Pennsylvania.
It's mind-blowing, and that's happening right behind the Wendy's.
A real lunar mission happening nowhere near one of NASA's traditional hubs.
We're trying to change the storyline here in Pittsburgh.
When people think of Pittsburgh, yes, they think of steel. Of course, we want them to do that. That's fantastic. But they're also thinking of robotics, almost second now.
From Steel City to Space City.
10, 9.
Our region's legacy built over generations.
But no city in America played a more significant role than Pittsburgh, Pennsylvania.
Alcoa, PPG, and Westinghouse all made Apollo 11 possible.
When Neil Armstrong stepped through the bulkhead of the lunar lander, he was stepping through Pittsburgh aluminum.
The flag on the moon has Pittsburgh roots.
Thousands of Pittsburgh workers took pride in putting a man on the moon.
Moves north and south.
And the way telescopes were designed more than a century ago. All thanks to astronomers in Western Pennsylvania. A legacy of innovation continues in 2026.
I bet you there's going to be a lot more Pittsburghers walking on the moon in the next 25 years.
I'd love to be an astronaut.
This is Chronicle, Mission Control Pittsburgh.
Tonight, a major peek behind the curtain for you at home as a company right here in Pittsburgh is on the brink of another chapter in space history. I'm Kelly Sasso with Mike Clark here on the city's north side, where a momentous trip to the moon was born, tucked right between a Wendy's and a McDonald's.
That's right, Kelly. So much is happening right here in the Steel City and across our surrounding communities to make this lunar mission possible. And it's only just the beginning. Pittsburghers are truly shaping the future of space exploration.
Status check. Go Vulcan. Go Centaur. Go Peregrine.
It's 2:18 a.m., January 8th, 2024, at Cape Canaveral Space Force Station in Florida.
T-minus 10.
Back in Pittsburgh, monitors glow in a room built from scratch. A mission control between fast food restaurants and steel memories. This is the morning Astrobotic's Peregrine lander reaches for the moon.
5, 4, 3. We have ignition. And liftoff.
And to see that take off and just rattle and rumble through the atmosphere, it was thrilling.
Launching a new era in spaceflight to the moon and beyond.
We were up on top of a rooftop looking out a few miles into the distance. You could see the rocket light up and then you start to see it take off and start to move into the air. And that's when you start to hear the rumble.
For the next several minutes, everything is perfect. A new rocket performs. The lander flies. Astrobotic founder and CEO John Thornton gives his first interview, beaming with excitement.
It's a dream. This is the moment we've been waiting for 16 years, and I'm standing in mission control.
The next 30 minutes were filled with confidence that Pittsburgh was about to become the first city where a private company would touch down on the moon.
So the spacecraft has an automatic sequence of, okay, turn on the radio, turn on the avionics, and establish communication back to Earth. And that's a nail-biting moment just in itself, because that's a system that we built, software that we wrote, and we established communication, and it was great. It was perfect.
It was about an hour into the mission, though, that the first signs of trouble came.
Slowly, we saw that pressure rise in the fuel tank, and we knew it right away. We're like, uh-oh, this is bad. And then when that pressure got to the break point, our sensor actually just stopped recording because it was well past its threshold, and then it blew.
Peregrine starts tumbling in space. Its solar arrays miss the sun, draining the batteries. In the span of minutes, the mission went from flawless to potential disaster.
We were watching the fuel gauge basically go down, and I remember sitting in the room with one of our engineers and our mission director, and the engineer was saying, okay, we just passed the point where we don't have enough fuel to land on the moon. So Mission Control here in Pittsburgh was scrambling to find a solution. And literally just a minute before we went out into that blackout period, Mission Control sent one command up to the spacecraft to try to get it to orient, come back around.
That single command leaves Mission Control on Pittsburgh's North Shore. Then silence for a planned blackout period lasting 30 minutes.
So we were waiting through that blackout period. Is the spacecraft going to come back alive? And then ultimately it kicked back on the other side, and we saw the battery had had risen in charge, and it was slowly rising. So the solar had turned around. The spacecraft was pointed toward the sun. It was stabilized. The spacecraft was reborn in that moment.
Reborn, but with a different objective now. Astrobotic's mission was forced to pivot from moon landing to meaning, an attempt to turn failure into evidence they could use in the future.
And for the entire 10 days, we were flying the mission from Pittsburgh. Everyone was just thinking about how we could make the most of the time that we had with the spacecraft, how we could do more things, take more pictures, get more science data for our payload customers.
Everything other than that valve worked. We didn't find any other significant anomalies with the spacecraft. So our software worked, our homegrown avionics worked, our batteries worked, every one of our payloads worked as planned.
And the Astrobotic team wanted to put them all to the test. Peregrine was assembled entirely at Astrobotic's headquarters on the North Shore in Pittsburgh. The systems to fly it were also built there from the ground up, unheard of in a city not traditionally known as a space city like Houston.
I was doing mission operations and mission control, so writing the procedures for flight, making sure that our ground software was developed correctly. So that's the software that we use here in our mission control center on the ground that talks directly to the spacecraft and commands it.
At any point, was there anyone on your team or maybe you yourself that said, wait, we're building like a mission control in Pittsburgh between the Wendy's and the McDonald's?
Yeah, it was sort of surreal. I felt like we were kind of the stealth space company out here where it seems like a lot of people knew that we had a contract with NASA and that we were launching something from Cape Canaveral, but didn't seem like an awful lot of people were aware of the depth of everything that we were doing, that we were building, designing, assembling, and piloting a spacecraft right out of here.
Outside the control room, the city watched and rallied.
I mean, how can it not be heartbreaking? But this is something that I think is very true across so many Pittsburgh companies, is our resilience. And I don't always like using the word grit, but there's a level of grit going on there where and they fully understand the chances of doing this are really tough.
They even had one of NASA's most experienced astronauts cheering them on.
I'm aboard the Columbus module.
Pittsburgh's own Mike Fink, who spoke to us from the International Space Station.
It's a failure when things don't work the way you want them, right? And that's life sometimes. Sometimes things don't work, but it's what you do about it with the data that you gathered. The Astrobotic team has really done a good job in understanding what went wrong and taking corrective actions to fix it.
Ultimately, they had a decision to make: bring Peregrine home or chase the moon again.
We made the very difficult decision, along with our partners, to direct the spacecraft to crash into Earth.
On January 18th, 2024, Peregrine re-entered the Earth's atmosphere and crash-landed in the South Pacific Ocean. What the team was left with were lessons.
So our system was what's called single string, meaning that each thing in the vehicle had to work in order for it to be successful, and one of them didn't.
Astrobotic is now using all of the data Peregrine collected for its next mission, Griffin, set to launch in 2026.
I think we will be stronger for it, ultimately, as difficult as that experience was.
Thanks so much for joining us tonight for Chronicle Mission Control Pittsburgh. Right now, we're inside Pittsburgh's Moonshot Museum. Just behind this glass, Astrobotic built the Peregrine lander and now is building the next moonshot, the Griffin lunar lander.
Tonight, we explore Pittsburgh's underappreciated role in the space industry, a city quietly helping America return to the moon. We're going to walk the neighborhoods where this story began, see the engineering up close, hear from the people behind these missions, and follow how a regional economy is reshaping what's possible in space.
And you know, it's almost impossible to think that all of this started in a bagel shop in Oakland. Pittsburgh's space story started in a tiny room above a bagel shop in Oakland. But even back then, on day one, it has been about going to the moon.
So back in 2007, a professor at Carnegie Mellon named Red Whitaker got us started. And I was one of the first folks he reached out to say, hey, do you want to be a part of this team? And originally it was to go to the moon as part of a prize.
The Google Lunar X Prize lit the spark, but a prize alone would not pay for a trip to the moon.
Within a couple of years, the business fizzled, and we were basically down to 3 people. It was me, Red, and one other guy. And we rebuilt things again, focused on building just a small book of business with NASA contracts showing that we can do related technology and execute well on that. In the very beginning, we were building out of Carnegie Mellon's High Bay, and we had a small office above the bagel factory right at the corner of Forbes and Craig.
Wow.
So it was literally like 200 square feet.
Astrobotic made history early on, selling a first-of-its-kind service, lunar payloads. That's the cargo a mission carries to the moon, be it science instruments, experiments, or technology. For Astrobotic, it was a way to keep the lights on.
And ultimately, we made some of the first sales of lunar payload in the world. So we sold a payload to a company called Astroscale out in Japan. And that was the world's first lunar payload purchase. And we had made that.
Skeptics laughed, but John never wavered.
So we were starting to make history in a few areas and getting people to believe in our story. Pittsburgh is not supposed to have space companies, but here we were in 2007, heading into a financial crisis, trying to build a business to fly and land on the surface of the moon.
In May of 2019, more than a decade after Astrobotic's founding, it got its first big break, a contract from NASA.
And we were awarded an $80 million contract to fly and land on the surface of the moon. I remember getting the phone call. I remember my whole body went numb for a moment.
That's the contract that allowed the team to build Peregrine. And from there, Astrobotic grew from a staff of 18 to hundreds, and from a single room to a 47,000 square foot headquarters on the north side. In 2022, the Moonshot Museum opened, letting the city watch the lander take shape in real time. And the next chapter is right here in Pittsburgh, getting ready to fly again.
Our goal then was to land on the moon. Our goal now is to land on the moon. We still see it as the future.
It's almost like the Holy Grail.
It may be the hardest test yet when Chronicle returns, the high-stakes moment that could define this next mission.
Welcome back to Chronicle Mission Control Pittsburgh. Pittsburgh took its shot at the moon and learned, and now the next lander is on deck.
That's right. Just behind this glass is the Griffin lunar lander, nearly complete. From redundant systems and new checklists to procedures born straight from Peregrine's tense first few hours in space. This is a story about redemption and a city getting back up. Pittsburgh learned hard lessons with Peregrine. Now, the city is building its answer.
I am so proud of Astrobotic and the other companies in Pittsburgh, for the space race. And if anybody can do it well and land on the moon, it's this team.
Just like Peregrine, Griffin is being built entirely in Pittsburgh. Griffin is built to haul over 1,000 pounds and to land where it's hardest, at the South Pole.
We'd like to be able to operate for up to 10 days, which is a lunar day. We're going to go to the South Pole. So after 10 days, the South Pole comes into darkness and we lose the sun to be able to recharge the batteries. It's almost like the Holy Grail. It's called Survive the Night, because when you hit the lunar night, these temperatures go just really extreme, freezing temperatures.
The moon's south pole is made up of shadowed craters that lock in water ice, the raw material for drinking water, oxygen, and rocket fuel. Nearby sunlit ridges could provide long power windows. That's why many scientists believe the South Pole could be the best place to land, work, and one day build a base. Now, another big difference from Peregrine is Griffin's design.
And in the propulsion system in particular, we've redesigned the architecture. So now we have two dissimilar valves that would both have to fail, and we have tested the heck out of those valves. And we feel very good about this next mission.
Testing has been a massive part of the Griffin mission. Not just the hardware, but the way the team flies.
We thought about our experience operating the spacecraft in space and thought about ways that we could make sure we as a team were more prepared to encounter any sort of anomaly we might in flight.
Olivia Gustafson was in the control room for the Peregrine mission. She'll be in there again for Griffin, this time as flight director, one of 2 women with that position.
A flight director is essentially the lead of the team in the Mission Control Center, making sure that everything is going according to plan, maintaining health and safety of the spacecraft, making sure the team has situational awareness.
It's not just the lander being custom built here in Pittsburgh, it is the entire supply chain.
We have a big local manufacturing community here in Pittsburgh, and that really helps us out. Most of the lander is made of aluminum. That comprises over 500 components, and the vast majority of those were made at local machine shops here in the Pittsburgh region.
Once the lander is finished, it will be sent out to NASA Glenn's Neil Armstrong Test Facility in Sandusky, Ohio.
And we subject it to the same kind of rigors you would see in the environment that is space and the environment of the rocket when we launch it. Because once we launch, there are no take-backs, right? If something breaks, we can't just bring it back here and fix it, so we have to get it right the first time.
Once it survives the shake and vacuum, engineers turn to its virtual twin, stress testing propulsion, heat, and dust in simulations by the tens of thousands.
Astrobotic leaned in, and we're collaborating closely with them to figure out how they can build, test, and optimize their products before they leave Earth. Heating up, cooling, fuel efficiency, vibration, the lunar surface, dust getting in there. I mean, we could model all of this.
And they don't have to go far. ANSYS, the Canonsburg simulation giant, has been key in astrobotics testing.
They're able to run tens of thousands of what-if scenarios because you only get one shot. I mean, this is the challenge with space.
Griffin will carry a rover and international payloads to the South Pole's rugged edge.
We've got a commercial rover. We have international customers on there. We have built our own Cube rover. The European Space Agency has a payload there. We've got a bunch of different payloads that are going to be flying on here.
I'm actually a lot more optimistic because we stress tested our team in the worst possible way.
Justine Kashnitsa leads the Keystone Space Collaborative and is married to Astrobotics CEO John Thornton. She has seen this ecosystem up close and how Peregrine was proven under pressure.
To know that our avionics unit was working flawlessly, to know that our payloads were all activated and working, gives us so much hope that the next time we're at this, we're almost there.
And for a city building its place in space, this mission is more than a landing.
And this is something that's not just great for Pittsburgh, it's great for the world. And if Pittsburgh can be the kernel of that, I'm in.
When Griffin lands on the moon, it's a big deal for the city. If Pittsburgh can land on the moon, Pittsburgh can do anything.
No city in America played a more significant role than Pittsburgh, Pennsylvania.
Millions watched the first steps on the moon, thanks to Pittsburgh. And one of history's most iconic images. That has Western Pennsylvania roots too. That's next on Chronicle.
As we continue to look at what's happening now in Pittsburgh to make missions to the moon a reality, it's also worth remembering our region's space legacy stretches back more than a century.
Did you know modern standard time was pioneered right here in Western Pennsylvania? Pittsburgh's Allegheny Observatory was also home to groundbreaking astronomical research, even the design of telescopes.
And 100 years later, local companies like Alcoa, Westinghouse, and PPG helped make Apollo 11 possible. In fact, even the first flag on the moon has Pittsburgh roots. The world watched in amazement on July 20th, 1969.
One small step for man.
Apollo 11 mission commander Neil Armstrong making history as the first man on the moon. Heinz History Center CEO Andy Masek says millions of people were able to see Armstrong's accomplishment because of sophisticated Pittsburgh technology.
Those images were brought to us live here on Earth from Westinghouse cameras. Those cameras had to function in the temperature extremes in outer space, and They look grainy and black and white to us, but that was remarkable technology.
The lead astronaut and pilot in command carried a whole lot of Pittsburgh with him, including an engine block and crankcase cast from aluminum supplied by the Pittsburgh Reduction Company, later known as Alcoa.
A local engineer named Homer Smith did the calculations for the moon landing, trying to get as precise as possible. He used this slide rule. Thousands of Pittsburgh workers took pride in putting a man on the moon.
North American Rockwell in Pittsburgh built the critical command module, Columbia, that carried the astronauts to the moon and brought them home safely. Rockwell was also part of the team that helped build key components of the Saturn V rocket, along with Pittsburgh Plate and Glass.
The F-1 engines that propelled this rocket into space, it was something that humans had only dreamed of before 1969.
The Apollo 11 crew returned to planet Earth using respirators made by Mine Safety Appliances. Pittsburgh was a hub of astronomical research and innovation more than 100 years before the Eagle landed on the moon. Founded in 1859, the Allegheny Observatory became home to powerful telescopes and early scientific breakthroughs. The first director, Samuel Pierpont Langley, helped create our modern standard time system. John Alfred Brashear is credited with building the world's most famous Victorian telescope. 100 years after the Allegheny Observatory opened, scientists at the Westinghouse Astronuclear Laboratory were testing nuclear rocket technology.
Pittsburgh has really grown a lot in the space industry.
Today, astronaut Mike Fink, a Pittsburgh native, is living proof how far the Steel City has grown.
On one hand, hard to imagine, how about that? But on the other hand, not surprising. We have a lot of smart people in Pittsburgh. We got great colleges. We got a great education system. We got hard workers. We know how to make things, right?
While Pittsburgh played a big role in the Apollo mission, the work didn't begin or end there. The Blahnox Company built early radio towers in the U.S., expanding into the manufacturing of NASA's communication structures. American Bridge worked on the massive vehicle assembly building at the Kennedy Space Center with help from Alcoa's specialty steel. A Pittsburgh native is also responsible for one lasting image from the lunar surface, deployed by Neil Armstrong and Buzz Aldrin.
He graduated from South Hills High School. He never went to college, but he was a natural model builder. When they said, we need a flag to fly on the moon, to let the world know that Americans got there first. And he thought about it for a minute. He said, well, you know, there's no wind on the moon. If we put a flagpole there, it's just going to hang there like a limp rag. So he said, I've got an idea. He remembered how his mother hung curtains, and he developed a cantilevered rod that swung out, and it made it look like the flag was flying in the wind.
Jack Kinsler bought the American flag at Sears and Roebuck for $2.50, packed it up, and flew it to Cape Canaveral himself.
That's the flag that's still on the moon today.
We have an opportunity to really unleash the next chapter of Pennsylvania's economic history.
From Pittsburgh's history to the future. Tonight on Chronicle, you'll see how the space industry in our region is quietly exploding.
It might be hard to believe, but Astrobotic here in Pittsburgh is just one of about 800 space-related companies across Pennsylvania, Ohio, and West Virginia.
And as traditional manufacturing skills evolve into lunar and aerospace technology, a Steel City nonprofit is making sure that everyone has a place in this growing industry. Western Pennsylvania has quietly grown into a launch pad of innovation, the center of a tri-state effort called the Keystone Space Collaborative, a regional partnership uniting companies, universities, and startups.
Across Pennsylvania, Ohio, and West Virginia.
Justine Kuchnitsa helped pilot Keystone to prominence, knowing how the space industry in Pittsburgh was ready to take off.
We mapped all of the companies in the Butler, Beaver, Allegheny County area that were prime contractors and getting money directly from NASA or the DoD for space work. That number, this was 2021, was over 100 companies. Really, it tells the story that we actually have a much stronger space base here than I certainly expected.
The emergence of the high-tech success rooted in Pittsburgh's past and fueled by local universities. Justine envisions a vibrant, connected ecosystem where students, startups, and established companies see aerospace as a career path and a civic identity.
It's huge for especially just keeping people here, right? It's whether it's people grow up in Pittsburgh or people coming in from, like myself, from areas outside of Pittsburgh, being able to come here, learn a lot, and then be able to stay here because there's so many companies that want to come and use that talent pipeline.
The pipeline includes the success of Astrobotic by founders who wanted to redefine lunar logistics.
We have a lunar company that has already flown one spacecraft. We're getting ready to fly the second one, and we expect we're going to be flying more after that. So Pittsburgh is going to be known as a lunar city.
Many legacy companies, so important to Pittsburgh's growth and economic stability for generations, also getting a piece of the pie, and they credit the Keystone Connection.
A lot of companies have been involved and engaged in the space sector, and Keystone Space has done a great job bringing that information and bringing the companies together, not just so that folks realize there is an ecosystem in this region, but also to help collaborate.
We're sitting at this unique intersect of this energy infrastructure capability that we've historically had, and then the innovation capability that we've had. And if you marry those two, and I think space sits exactly at the corner of, at the heart of those two things, we have an opportunity to really unleash the next chapter of Pennsylvania's economic history.
The Moon's supply chain runs right through western Pennsylvania.
We don't even have any signs here. We're a pretty hush-hush operation, not by design, but we do some pretty cool stuff right under people's nose.
From the same team that once moved the giant Heinz Field ketchup bottles to companies you drive past every day, Chronicle takes you behind the scenes to see some incredible technology.
Welcome back to Chronicle Mission Control Pittsburgh. If you think only Houston or the Cape are home to space innovation, wait until you see what's being built right here.
3D printed thrusters in Mount Pleasant, robots in Bloomfield, simulation power in Canonsburg, and a family company that moves the Moon hardware the same way they move the ketchup bottles from Heinz Field. This is a look at the lunar supply chain, Pittsburgh style.
So you're about to see a Lego crash that happened in simulation versus reality to show you how accurate this technology stack really is. It's mathematics, right? We're simulating physics, which is really math. So this goes to show that we're not in the business of just creating, pretty pictures and renderings. Like, this could be life or death.
What you're seeing is the core of Canonsburg-based Ansys, virtual testing of real-world hardware. Founded by famed Pittsburgh engineer John Swanson, the company is now one of the most valuable in all of Pittsburgh. In early 2025, California-based Synopsys completed its $35 billion acquisition of Ansys. These simulations have proven invaluable for Astrobotic, saving the company time and money.
We can do an awful lot at the design stage that years ago had to be done with physical testing.
The number of variations is nearly impossible, so you have to lean into simulation to run billions of scenarios.
And when Astrobotic needed to stress test its propulsion, the partnership paid off.
The goal was they can run tens of thousands of what-if scenarios and optimizations before their product ever left Earth.
When I was at Tepper.
Just across the Bloomfield Bridge, a different kind of factory. Modular robots building the future.
So our mission as a company is to make it easier to build robots. our main product is a platform for robot development. So you can think of it as like Legos for robots.
For construction in space, but
The vision of Heavy Robotics is multi-robot teams that assemble structures on their own.
So the whole idea here is to create a team of robots that can build structures autonomously.
it expands beyond space, right? If we can create actuators or technology that works in a radiation harsh environment, that goes beyond space.
In our east, rocket parts take shape one layer at a time.
6 years and we've already delivered multiple engines to different companies. We've delivered A110 thrusters for Astrobotic, and that's going for their attitude control system on their Griffin lander.
These are small engines, precise, light, and critical for touchdown. Agile Space Industries, a factory spin-out from Westmoreland County Community College, now hums inside RIDC Westmoreland.
Ones that we delivered to Astrobotic specifically are 0.8 of a pound.
Some of what's being printed here will fly in Earth orbit too. What we're seeing right here, being made in Mount Pleasant, Westmoreland County, is going up to the International Space Station.
Absolutely. We don't even have any signs here. We're a pretty hush-hush operation, not by design, but we do some pretty cool stuff right under people's nose.
And the roots of this space network run deep, back to a different era in space and to this quiet building in Monroeville. Here, engineers developed a patent that changed how NASA communicates and how the rest of us do too.
We often are categorized as one of Pittsburgh's best kept technology secrets.
In the analog 1980s, Compunetics built a digital switch, the modern conference call NASA needed and the one many of us still rely on.
Developed a switching technology which was rather unique. It was a very novel way of performing telecommunications switching for both data and voice.
When NASA put that idea out to bid, the little company from Monroeville out-engineered a telecom giant.
Sure, AT&T was a much larger company, but Compunetics was a handful of engineers, but they won.
Digital made missions clearer and faster to reconfigure. And that space-proven tech soon powered millions of calls back here on Earth.
Very quiet company. Behind those walls, you know, is where the conference call was invented. And behind those walls is where so much communications for NASA, the space shuttle, like all these things that like were just fundamental to us being leaders in technology in space happened here in Monroeville.
We've been very conscious about trying to build up the local supply chain, putting as many contracts out to the region as we can. We do about $13 million per year in subcontracts to Pennsylvania companies. 99% of the machined parts on the Griffin lander are made by Pittsburgh machine shops here in town.
And here's a question for you. What do the ketchup bottles taken off of Heinz Field have to do with Astrobotic's Peregrine lander? Well, the same Pittsburgh riggers were in charge of moving both.
They just sent us, this is the spec for this actual container that it's going to be in, but we didn't know what was in it. We did have to sign an NDA, obviously, so that was exciting when we saw that it was a lunar robot, that we were quite interested.
Steffen Industries knows if you're moving something that only exists once, every step matters.
It was priceless, and there was only one of them in obviously the whole world.
Through meticulous planning, the lander made it to Florida without a hitch.
It's nail-biting to think that it's exposed out on the road. I mean, you could have an accident, you could have it run into something. So it's really important that we partnered with a really good transportation company to make that happen.
From simulation and robots to 3D printed thrusters to that white knuckle cross-country move, the Moon's supply chain runs through Pittsburgh.
We got hard workers. We know how to make things, right? That's what Pittsburgh's all about.
I had no interest in space before I joined this.
Real-life training, preparing young students for the next era of space. The hands-on opportunities right in our backyard. One Chronicle continues.
Astronomers and engineers inside the Allegheny Observatory more than a century ago shared the same problem-solving mindset that now is fueling this whole new generation of innovators. High school and college students are already working on real technology that's making a difference.
And the opportunities span far beyond astronauts and scientists. As you have seen throughout our program tonight, they don't even have to leave the region to build a career in space. For students at North Allegheny High School, this experience is out of this world.
I had no interest in space before I joined this.
They're not just studying aerospace, they're living it.
If I didn't take this chance, I would never be where I am right now, academically and with my opportunities.
Liz Franklin is a member of the junior ROTC program and joined the Stellar Explorer team as something to do after school. She and her classmates are now reaching for the stars and beyond.
I think it's really cool how we can leave the Earth, honestly, and one day, maybe when I'm a test pilot or after I'm through my pilot career, I could go and be an astronaut. I mean, I'm not taking it out of my options. I'd love to be an astronaut.
They're working like astronauts, preparing for the Stellar Explorers National Space Design Competition.
I think it's exciting how we're starting to explore different planets. I think that's the most fascinating part, and how we're starting to find like different bacteria and water on the polar regions of Mars and the Moon.
It's one of the few fields where we don't know everything yet. There's so much more to do, and every day it seems like we're expanding, we're sending out a new spacecraft or a new satellite to another planet.
Suraj Raina is the Stellar Explorer commander, leading his fellow students using system simulation software, real-world technology to create space designs.
We start out, we design the orbit of the satellite, as well as we choose what goes on the satellite. So that includes the camera and the data recorders, for example. And from there we go into the rocket itself. So what rocket are we going to choose and where do we launch it from? And then a couple of other things like insurance, accounting for weather, fun things that kind of make a big difference when the final scoring.
And you get to choose. We're going to blast off from Florida, we're going to blast off from Texas, we're going to go to California.
Yeah, so as many options they give us, we get to choose, and that's so cool to just have such a open berth of opportunities. It really makes you feel like you're doing the actual thing.
It's any teacher's dream to see that light bulb come on and watch young people succeed. I mean, that's what it's all about.
These tigers guided by the watchful eyes of retired Lieutenant Colonel Don Accomando.
Look, they're the experts in space exploration, not me. But having the opportunity to work with young people and see them succeed at this level is a great honor.
Watching students apply aerospace engineering, physics, and mission design to real-world space challenges, he says they're proving the next generation of explorers may be sitting in these North Allegheny classrooms.
I'm constantly asking them to look up from their phones, to look to the skies. As a matter of fact, we had a cavalcade of planets on parade, not only the moon, but Jupiter, Venus, and Mercury, all three together. And it was just that next day that we were talking about Kepler's law of orbital dynamics. So you have a chance to remind them to just look to the stars, look up once in a while. And these kids do that.
The stargazing and planet plotting has Elizabeth dreaming of new destinations.
I think it's important for high school students to know that there's so much more than the Earth, and we can take other planets as an example of our Earth, like, hey, we could live on this other planet if we could travel at the speed of light, or this is what it takes for life to form on different planets.
Suraj says his leadership here connects him to another NA Tiger and hometown hero, astronaut Woody Hoburg.
It's so inspirational because I know so many of my teachers, and you can ask them and they'll go, oh yeah, I taught Woody, I know him. And they'll tell you he was just like so bright-minded, and being able to just kind of almost live his life and be able to understand what he did and know that, he did the same things that I'm doing. It's just kind of cool to think about.
We have a very aggressive timeline working with NASA. Their objective is to have a nuclear power plant operating on the south pole of the moon by 2030.
Next on Chronicle, you'll see the Pittsburgh company helping NASA fast-track a nuclear power plant on the moon.
We just met the next wave of students ready to build this new era. The question now is, what are they building toward?
Well, after Griffin, the moon needs power, roads, communication, and machines that can work in permanent shadow. But to what end? How would a permanent foothold on the moon reshape life on Earth and our place in the universe? Here's what could come after Griffin touches down. After Griffin, the mission shifts from landing to living and working, and why any of that would matter back here on Earth.
What an investment the space program has been for our country, and what an investment it is for our future. We have a super high-tech economy right now, and that's directly traceable back to the early space program with Apollo and going to the moon and how it motivated our country. It's the same thing.
In Pittsburgh, the work of living there is already underway. At Astrobotic, Steve Clark, former vice president for space programs, says the next era isn't a visit, it's a work site, with commercial companies flying routine missions.
There are minerals there on the moon that can be mined and actually brought back to Earth that would help us here.
So why stay? Clark says 2 reasons: discovery and supply. The moon is a record of Earth's past and a toolbox for what comes next.
There's so much more to learn about Earth that's trapped in the lunar surface there, because it's almost like a time capsule, because there's no atmosphere. Nothing has blown away the evidence of what happened millions of years ago.
But before humans can stay, Pittsburgh lays the first wires.
We're going to set up an electrical grid so that robotic systems and human habitats and so forth can run off this electrical grid.
The company is on the forefront of lunar electricity with its Lunar Grid Light.
It's basically a rover with a solar array tower on it that can drive off the rover, the lander, and it can have a cable attached to it, and it can go away from the lander and have a solar tower and generate power.
Solar starts the grid, but to survive the 2-week night and scale, another Pittsburgh giant steps in.
So solar has that limitation of the lunar night, the lunar day. It's charging in the lunar night, it's using up that electricity.
At Westinghouse, Ryan Blinn leads space and energy systems, building nuclear power for the moon.
The nuclear aspect of that, coupled with it, could provide that continuous power and large-scale power that's needed.
So what would nuclear on the moon look like?
So unlike here where we have tons of operators, maintenance folks, security guards for the power plant, this isn't going to have that. It's autonomous. It runs by itself, which is great.
That sounds like a pipe dream. You would be surprised to hear how close they are. Now, this is just a concept today, but the build is moving fast.
We have a very aggressive timeline. Working with NASA, their objective is to have a nuclear power plant operating on the south pole of the moon by 2030.
If anyone can do it, it is Westinghouse, whose origin story is a Pittsburgh story, from AC power to the first nuclear power plant to this.
The good thing is it is small. It is achievable. We understand the materials. It can be built. What we need to do is some of that final testing and evaluation.
And for anyone asking, a reactor on a rocket? Blinn points to design simplicity and layers of oversight.
The technology is different. It's much more simplified and I would say naturally safe how we use those components within it. There's a lot of very specific regulations with NASA, the Department of Transportation, the FAA. They're all factored into the evaluation cases.
We've shown you how Canonsburg-born Ansys, now part of Synopsys, powers crucial simulation for space work. In a poetic return, Ansys, a Westinghouse spin-out decades ago, is now helping Westinghouse design for the moon.
And then 55 years later, we're helping them design nuclear technology to put on the moon, which is no easy task.
Anthony Matarazzo says this region is uniquely positioned to model the whole system end to end.
So think about the need for communications and being able to optimize, the rover to the base station to the antenna and the satellite. So this is like a systems of systems simulation. I call it like a supermodel, and we're super well positioned in the region to capitalize on that.
Power is one pillar. The other is building with what the moon gives you. We've already shown you how Bloomfield-based Heavy Robotics is on it.
Boggling to think of all the different things that need to go into place, things we take for granted here, where on the moon or Mars or in space, it's just a blank slate.
And the payoff is more than mining. Zero gravity itself can change how we heal and how we make things.
Figuring out how therapeutics work in that environment can really provide critical information to then bring home to Earth and figure out how you do therapeutics for certain conditions.
The moon is where we practice, close enough to learn fast and fail safe. But Clark says it's just the dress rehearsal for Mars.
It's a good test bed before we go to Mars because it's close. You can also fail there, and if you have crew there, you can bring them back pretty quickly. Mars is a different story.
As engineers continue to push the boundaries, our region is proving it is a critical hub for the space industry. Astrobotic's Griffin mission is still being finalized for a 2026 lunar launch.
And as we've seen throughout the history books, Pittsburghers are shaping what comes next, and we will be watching. On behalf of our entire Chronicle team, thank you for watching, and good night.